All right, so we're going to talk about transformers now, which is basically just a sort of an extension of what we've already talked about with magnetic coupling. We've been sort of talking about circuits that are coupled almost unintentionally. You know, they might be in close proximity to one another in a circuit, and we just have to account for that mutual inductance that induces voltage or current in another part of the circuit. But with transformers, we're almost exclusively talking about intentional coupling. Okay, we're trying to couple these two things together because we can get some really interesting behavior and build some really awesome circuits using transformers. Okay, so what is a transformer? So a transformer is a four-terminal device. You can think of it as having two input terminals and two output terminals. And I have a couple of figures from the textbook drawn here. And so if we look at either one of these, they both basically have two coils, one in red and one in blue. Let's just start by looking at this one. Each has a different type of a core, right? We can see that this is more of a squared off rectangular kind of a core shape, and then this here is a cylindrical core. But you notice that the red wire and the blue wire are both wrapped around the same core in both cases, okay? So you have these two input ports and these two output ports on this first transformer here, and then you have the two input ports and the two output ports on the second transformer here. Electrically, the only difference here is that we're using two different cores. Electrically, these are basically the same component. These are both transformers. They would both look like a transformer looks, which basically is going to be some dot convention showing two coupled coils. And on the next slide, we're going to look at the symbol for the transformer. The key is that you'll see these two lines in between to let you know that those two coils are wound around the same core. Up to this point, we haven't seen those lines. We basically just seen two coils like this, which means they're not coupled by any magnetic material. These cores are made out of some kind of magnetic material with high magnetic permeability, which is this mu that we've been talking about when we talk about inductances. Higher permeability gives better coupling. And yeah, basically, like I said, we have these two lines in here that we're going to see when we move on to the next slide. And whenever you see the two lines, you'll know that you're looking at a transformer rather than maybe some unintentional coupling that's going on. So four-terminal device, of course, we've got 1, 2, 3, 4 terminals here on both of these. 1, 2, 3, 4. Basically, you can think of it as an input and an output port. What the first one is called, basically the first two pins make up what's called the primary port or the primary side of the transformer. And the secondary side is the output. Okay, so you got the input here, which is called the primary. Same thing going on here. Okay, and then the output is the secondary. Okay, and then basically these two coils are electrically isolated for the general case of the transformer. They're not electrically connected. They are wound around a magnetic material. This material is not electrically conductive, though, so they're not connected electrically. This green dotted line that you see in here, that is the magnetic flux line. So basically our magnetic lines that we've been drawing this entire time, the magnetic field lines, those lines pass through this magnetic material. And so these two materials these two windings are coupled magnetically through the common core material, this right here. And the same goes for this core material right here. You can see that it says transformer core. They don't label it here, but this is the transformer core in this case. And basically these are just two different geometries. The geometry of the transformer matters a lot for a number of reasons, for weight, for size considerations, for coupling. And so you'll see all shapes and sizes of transformers, and when we get to the end of this module, I'm going to show some practical ones. These are just figures from the textbook like I mentioned, but I think they're good figures. And so the key concept of the transformer is that a voltage across one winding induces a voltage across the other winding. I probably shouldn't have used the word in here. Should have used the word across. So if I apply a voltage across this winding, I get a voltage across this other winding. But the key to transformers is that they only work for AC circuits, okay? So they don't work for DC circuits. If I were to apply a DC circuit here, or a DC voltage here, I would not get a DC voltage on the other side. it's important to keep that in mind, that transformers only work for AC. I should have definitely noted that somewhere. And so basically, like I said, they're used to induce. So if I put a voltage here, I'm going to induce a voltage here. But this voltage can be scaled based on the number of turns. So you'll see that these two different transformers, they both highlight the number of turns. N1 here, N2 here. That ratio of turns is very important for determining how voltages and currents get transformed in these circuits. So if I have more turns on one side than I do on the other, the side with more turns will have more voltage. And that's just a property of the electromagnetics. Okay, so just right from the name, a transformer is called a transformer because it's used to transform voltages, currents, and impedances between the primary and the secondary. We can transform a small voltage to a large voltage. We can transform a small current to a large current, etc. Okay, so that's the key, or those are kind of the overview of transformers, some bullet points here that I just wanted to touch on before we start solving them electrically and looking at circuits. Just want to talk about what they look like, what they are, what they do. And so I'll end this video here, and in the next video we'll continue talking about what transformers are and what they do. And within no time we'll be solving some example problems. All right, so I'm going to end this video right here.